Howdy, this is a video on section 6.3, Logic of Identity, based on the textbook First Course in Mathematical Logic by Patrick Suppes and Shirley Hill. It will be a basic introduction to identity. Let's get started. Let's talk a little bit about the copula and its relation to identity. Now here, all things do depend upon what the meaning of is. The copula, which is the to be verb, can relate terms in different ways. The to be verb is usually of the form of is, or is not, or are not. Compare these two examples from the Suppes Hill textbook. The first example we have Elizabeth II is the Queen of England, and in the second example we have Elizabeth II is a woman. Now clearly how we're using the term is different. In the first example we have identity. We're saying the Queen of England is identical to Elizabeth II. So we have an identity is. In the second example, we're told Elizabeth II is a woman. Now clearly, a woman is not identical to Elizabeth II. Rather, we're saying being a woman is a predicate of Elizabeth II. So here we have a predication is. And in this section, we're concerned about the identity is. Now the identity sign belongs only between terms, and they must name, or they must be names for one and the same thing. So again, here we have Elizabeth II is identical to the Queen of England. Identity isn't between things. Again, rather it's between two different expressions that refer to the same thing. It's never the case that two different things are identical. For example, two cows are just two cows. We have a cow over there, and then we have another cow over there. Both are cows, but they're obviously distinct cows, right? We'll just jump into exercise 7a on page 232 of the textbook. We're told to translate the following sentences using the identity sign wherever appropriate. The identity sign is just the equal sign. Identity is really an interesting philosophical issue. For example, what's the status of existence? Would it be, for example, just a predicate? Remember, we can make a distinction, for example, between the predication is and the identity is. Would existence, for example, be part of the predication is? If I say George exists, or God does not exist, would existence be a predicate? Now, interestingly, in the history of thought, most philosophers have tended to say that existence is not a predicate. In a way, so to speak, existence is another metaphysical category. Aquinas thought this, even David Hume, the skeptic, thought this, and, for example, Immanuel Kant would think this. And this has implications, for example, when it comes to arguments for and against the existence of God. But leaving that to the side, let's look at our sentences here. The first one tells us that July 4th is Independence Day. Here we have a straightforward identity, because July 4th and Independence Day really reference the same thing. They're just using, so to speak, different expressions. Hence we can say lowercase j equals lowercase I. July 4th is identical with Independence Day. Number 2 tells us that Sir Francis Drake was a privateer. Clearly, privateer is just a predicate. It's not identical to our subject, so we'll translate this as capital P lowercase d. So lowercase d represents the subject, and the capital P, of course, represents that predicate, privateer. Number 3 tells us cats are felines. Felines, again, is just a predicate. It's not identical with cats, but note that cats is a general term. It doesn't reference a particular cat, but just all cats. Hence, we need universal quantifiers. We'll say for all x, if x is a cat, then X is a feline. Number 6, Franklin was the author of Poor Richard's Almanac. We have the individual person Franklin, and we have this author of. Those are two different ways to reference the same person, so we have an identity here. We'll say lowercase f equals lowercase a. Number 9 tells us if Mike is a photographer, then he is a boy I heard about. Overall, we have a conditional. In the antecedent, we have Mike is a photographer. Mike is a specific person, obviously. Photographer is a predicate. But in the consequent, we do have an identity here. He is the boy I heard about. In other words, we have capital P, lowercase m, arrow, m equals b. In other words, if Mike is a photographer, then Mike is identical with that boy. We have he is that boy I heard about. Number 10, if x is 3, then it does not equal y. So x is 3, we have an identity, and then an identity is being denied in the consequent. So we have if x equals 3, then x does not equal y. What about argumentation? After all, that's what logic is principally about. In here, we'll just be sticking with the Suppes Hill textbook. However, much more can be said on this topic. For example, if we introduce the existential quantifier, we can even construct sentences that specify exact numbers. We can say that there are, say, exactly 3 people in this room. But for now, we're going to look at identity only with the universal quantifier, be a much more narrow look. And here's an example of an argument. It's very basic, very simple, but here it is. We have premise 1. We're told that 2 is greater than 1. Premise 2, that 2 is equal to 1 plus 1, or that 2 is simply identical with 1 plus 1. And then we get the conclusion that 1 plus 1 is greater than 1 by the rule of identity with premises 1 and 2. Now clearly what's going on is that we're told that 2 is identical with 1 plus 1. We're told that 2 is greater than 1, but because 2 is identical with 1 plus 1, 1 plus 1 must be greater than 1, just like 2 is greater than 1. It's really as simple as that. I should also note, however, that a lot of textbooks do not call this a rule of identity. Instead, they call it the equivalence substitution. But for our purposes, I think I'm going to stick with calling it the rule of identity. After all, this section is much more narrowly focused than a lot of contemporary textbooks. This is maybe a more interesting argument. We'll translate it into predicate logic using our new tool of identity, and then we'll find out if it is indeed valid. Premise 1 tells us that all members of the committee live in the city. It's a universal affirmative proposition. We have a universal quantifier. So premise 1 will say for all x, if x is a member of the committee, then x lives in the city. Premise 2 tells us that the president of the society is a member of the committee. President of the society is a subject. Member of the committee is a predicate. Hence, for line 2, we have MP. Premise 3 tells us that Miss Jackson is the president of the society. Miss Jackson is the subject. However, the president of the society is just another way to identify Miss Jackson. We have not a predication, but an identity. And note that president of the society also shows up in premise 2 as a subject. So for premise 3, we'll say that J is identical with P, and then our conclusion is therefore Miss Jackson lives in the city. Hence we have CJ. How should we start? We should work with the first line. We have this universal quantifier. We can instantiate it. What can we substitute in for x? Well, we're dealing with the president of the society. We really should input P for x. So for line 4, we can get if MP, then CP by the universal instantiation of line 1. So if the president of the society is a member of the committee, then the president of the society lives in the city. And moreover, we know that from premise 2 that the president of the society is a member of this committee. So we could affirm that antecedent to get the consequence. So for line 5, we can get CP by modus ponens with lines 2 and 4. And finally, because we know that J is identical with P, we could simply substitute that J for P. Hence for line 6, we can say, therefore it does follow CJ by identity with lines 3 and 5. Miss Jackson lives in the city. Here's a good one. Edward could have seen the murderer's car. Ramsey was the first defense witness. Yet either Edward was at the party or Ramsey gave a false testimony. Yet in fact, no one at the party could have seen the murderer's car. Therefore, the first defense witness gave false testimony. All right. Seems valid intuitively, but let's prove it. But I always fear that I'm going to overcomplicate my translations or fail to be consistent when I'm assigning certain letters to certain expressions. So my advice in this case to me and to you is to look at the conclusion first. So let's do that. We're told that therefore the first defense witness gave false testimony. It's a simple subject-predicate relation. There's no quantifiers. We'll say therefore capital F, lowercase f. Lowercase f, the first defense witness, the subject. Capital F gave false testimony, the predicate. And we see the first defense witness show up in premise 2. We better assign that the correct letter. And likewise, we see gave false testimony in premise 3. All right, let's look at premise 1. We have Edward could have seen the murderer's car. We have a subject-predicate relationship. We'll say capital S, lowercase e. Premise 2, we're told that Ramsey was the first defense witness. Now the first defense witness simply refers to Ramsey, so we have an identity. Thus we'll have to say lowercase r equals lowercase f. We have to use that lowercase f. For premise 3, we have a disjunction. Either Edwards was at the party or Ramsey gave false testimony. Thus we can assign it capital P, lowercase e, or capital F, lowercase r. And again, we need to give that an uppercase F for gave false testimony, and of course we're referring to Ramsey there. For our fourth premise, we have, in fact, no one at the party could have seen the murderer's car. No one implies a quantifier. It's a universal, but it's a negation, so a universal negative proposition. Hence for line 4, we have for all x, if x was at the party, then it is not the case that x could have seen the murderer's car. So for all x, px arrow, not sx. What should we do? Let's instantiate. We have this line 4. What do we substitute for x? Well, it would have to be Edward, right? We'll have to substitute e. So for line 5, we can get pe arrow, not se, by the universal instantiation of line 4. If Edwards was at the party, then Edwards could not have seen the murderer's car. Moreover, premise 1 tells us that Edward could have seen the murderer's car, but SE is contradictive to not SE. Thus for line 6, let's double negate line 1. Now we can deny that consequent. So for line 7, we can get not PE by modus tollens with lines 5 and 6. It was not the case that Edwards was at the party, and now we can take into account line 3, which is a disjunction, and get FR by our disjunctive syllogism with lines 3 and 7. Now we have Ramsey gave false testimony. However, we know that Ramsey is identical to the first defense witness according to line 2. So for 9, we can therefore conclude that FF by identity with lines 2 and 8. So therefore, the first defense witness gave false testimony. The final two problems we will work on come from exercise 8b. We'll do number 7 and number 8. Number 7 asks us to derive 4 plus 3 does not equal 3 times 2, given three premises. The first premise has two universal quantifiers. This means we will gauge in universal instantiation twice. The question is, what do we substitute for x, and what do we substitute for y? We want to derive 4 plus 3 does not equal 3 times 2. So it looks like for x we want a 4, then we can get our 4 plus 3. Moreover, if we look at this consequent here, x plus 1 equals y, if we substitute 4 for x, we have 4 plus 1. For y, we're also going to want 4, then we can match the second premise, although, of course, those statements will be contradictory vis-a-vis each other. So for line 4, we can get for all y, 4 plus 3 equals y plus 2, arrow, 4 plus 1 equals y by the universal instantiation line 1. And then for 5, we can do another instantiation. We'll get 4 plus 3 equals 4 plus 2, arrow, 4 plus 1 equals 4 by the universal instantiation line 2. Notice that premise 2 says 4 plus 1 does not equal 4. This contradicts our consequent. We can thereby deny the antecedent. So for 6, we can say 4 plus 3 does not equal 4 plus 2 by modus tollens with lines 2 and 5. This left-hand side is 4 plus 3. We want that. The right-hand side is 4 plus 2, but we do not want that. We want 3 times 2. However, premise 3 tells us that 4 plus 2 is identical to 3 times 2. Thus, we can conclude that 4 plus 3 does not equal 3 times 2 by the identity rule with lines 3 and 6. For number 8, again, we have three premises. Here we have 3 quantified variables for premise 1. Question is, what do we substitute? We want to derive 3 plus 2 equals 5. And I believe we will want that to appear on this right-hand side of our biconditional. Thus, for line 4, we can substitute, let's see, 5 for x. So for all y, for all z, 5 minus y equals z, if and only if y plus z equals 5 by the universal instantiation line 1. And now we can work on our next variable, y. So for all z, 5 minus 3 equals z, if and only if 3 plus z equals 5 by the universal instantiation line 4. Then for 6, we'll work on the variable z. We can get 5 minus 3 equals 2 if and only if 3 plus 2 equals 5 by the universal instantiation line 5. We have this 5 minus 3 equals 2, and this appears, well, it doesn't really appear, but we have this 5 minus 3 at least with premise 2 is equal to 1 plus 1. However, we know 1 plus 1 is identical to 2. So we can use our identity rule very soon, but before we do that, let's use a biconditional law to get a simple conditional. So for 7, we can get 5 minus 3 equals 2, arrow, 3 plus 2 equals 5 by the biconditional rule or biconditional law with line 6. And now, for 8, we can get 5 minus 3 equals 2 by our identity rule with lines 2 and 3. So 5 minus 3 equals 1 plus 1. But 1 plus 1, of course, equals 2. And now, for 9, because we have 5 minus 3 equals 2, we can do a modus ponens inference to get 3 plus 2 equals 5. Let me just fix one thing. This would be the universal instantiation of 4. Alright, thank you so much for watching. Up next is section 6.4, Truths of Logic, and we will continue with First Course in Mathematical Logic by Patrick Suppes and Shirley Hill.